Alright, welcome to the Python program. My name is Kenya and today I'll be talking about the fundamentals of Python, the core of Python, the foundational blocks upon which the language Python is built. Python is a programming language like many other languages out there like C++, JS, PHP, and the rest. Um, Python is an interpreted language. We have two kinds of programming languages that are interpreted and those that are compiled. In most cases, compiled languages are a lot faster than interpreted languages, while interpreted languages are most times very easy to understand from the uh, from the human point of view. Okay, so let's go straight into it. So as I said before now, Python is interpreted, so Python is a lot more easy to understand and it is very easy to use. So anybody from people who are not software devs, people who did not study computer science can get to learn it, can get to understand it, and can also use Python for their day-to-day activities. Okay, so let's go straight into getting understanding, doing some setup and basic understanding of how it works. Okay, so this program is called PySphere. PySphere Nigerian is an online Python training program designed to equip individuals and people from less developed regions with essential programming skills to drive local innovation through hands-on learning, specialization. As we go on in this program, you can actually specialize in different areas, in different niche areas, but this is just week one, so we're trying to get we're trying to make the entire scope so that you understand the core of what Python is before we begin to apply it to our different niche as we go on. Yeah, so that's just it. So this program is called PySphere, and we have great support from the Python Foundation. The Python Foundation has made this possible, and we also thank them for that. So how do you print out the first command in Python? Uh, Python is very easy, unlike languages like C++ and PHP, where you have to declare variables and do a lot of things, and printing out techniques are always very complex. You have to say console this or equal that. Python makes it very easy. So with that human-like command on screen on the whiteboard, you can see that we are printing out welcome to Python training. Now, before we do that, you may want to set up. So let's quickly talk about what Python is and then we do some setup, right? Okay, so Python can be used in different areas like I mentioned before now, in areas like web development, data science, automation, AI development, and the rest. Um, I've also explained that the syntax in Python is very readable. Now, before we go on, I would like all of us to install Python in our different uh, workstations, in our laptops, in our systems, in our phones. You can get Python on all of your devices. Uh, to install Python, it's very easy. You just have to go to python.org and get the installable. Uh, Depending on your OS, you can get the Windows installable, or if you're on Linux, sudo apt to install Python or Mac. Yeah. So let me join you do that so that you see a clear example of how it works. Um, so we'll just be creating a new tab here, and if you just go download Python, um, so you can specify download Python for Windows, download Python for this, and you can easily get it. um, yeah, so another thing we also have to um, another thing we also have to get is a test editor, an IDE, an integrated development environment. So you can use any of them. There are a lot out there. We have VS Code, we have the default one for Python, PyCharm. We have Notepad++, uh, and the rest. We have Atom. There are just too many. Yeah, you can even build yours. But just for clarity, just use VS Code. I just use VS Code. You can use PyCharm, just be free. So you can see, you can download the latest version of Python here from the python.org website. Yeah. So based on your distro, when you come on that download, you see the different distributions there, and you can download the one that fits your need. Now, to download an IDE or a text editor, you simply Google the text editor you want. It can be VS Code or the rest, and you just use them. So if you go to the VS Code official site, there are also different distributions there for Mac users, for Windows users, for Linux users, and so on. If you are on a Android device, maybe you don't have a system but you really want to learn, uh, you can actually install it using you can install an app called PyDroid. It will help you as we go on. You can also install an app called Themis. It's more of like a console on a mobile device. So on that console, you can install Python and do the rest. Okay. Um, some of our instructors actually have videos on Android devices. So if you're one of them, reach out to those set of instructors. Okay, so writing your first program, let's write our first hello world program. And as you can see, it is very easy, right? You just say print. Since print is a command, we're going to bring in the brackets, and then we specify what we want it to print. What we want it to print is a string called hello world. Because it's a string, that's why we're adding the quotation mark. If it was a number, we would just say print bracket open 1 or 1 plus something or 3 bracket close. Or since it's a string and we want it to be printed exactly that way, we add the quotation mark. Okay, so this is another one. Let's look at what variables are and what data types is. So from the very first time we invented, engineers and scientists brought up computers, computers were mostly used to calculate. So the basic calculation that happened was simply integer addition and multiplication. So you could add 2 plus 3, 2 plus 6, but as time went on, people wanted to divide, and that brought in a new data type called float. Because most times when you divide numbers, especially numbers that are not totally divisible, there will be remains, there will be remainders, and those remainders will lead into what we call floats. So an integer are normal counting numbers, 1, 2, 3, 4, 5, and so on. Floats are those with a decimal point, like 2.5, 2.678, and so on. str is short for string. Now, str are those ones that have quotation mark. If you look at the three variables declared on the whiteboard, you can see name. Name is a string, and you can see it has the quotation mark. Yeah, that's one way you can know if this data type is a string or if it's not a string. Okay, so then the last data type there is bool. The bool is mostly a binary condition of true or false, on or off, and so on. So I need you to understand that what you are saying on the whiteboard is a simple code snippet. So if you take this simple code snippet and run it in your IDE, it will still work just fine. So before we go into do some testing, now how do we control basic input and output? Python uses input command for to get inputs from the user, which of course is very easy and simple. Then it uses the print command to send output to the user. So if you get data from the user, like the user's name, and you want to maybe greet the user, you can use the print command like seen on screen here. So we declare the variable called name. Yeah, I think I missed out something and I didn't really make justice to what variables are. Now, variables are a memory location. So um, think of them like a box. So on the whiteboard, you can see we created three boxes. The first box is name, the second box is age, and the third box is student. Now, these three boxes can actually be empty or they can be filled with something. When I say filled with something, I mean filled with data, So you can see there that we assigned the word ada to the variable name. What that implies is whenever I call name on my code, Python automatically understands that uh, it will bring out the content inside the box of name, inside the variable of name, and that content is ada. Yeah, so same thing when I call age, Python will bring out 25, and same thing if I call it student, Python will bring out true based on what I assigned to that particular variable. Yeah, so in that same way, when we say name equal to input and we specify some string, when we run this code, Python will ask the user for some input. We asking the user to enter their name. The moment the user enters their name, it is saved into the variable of name, into that box called name, and then it is printed out. We telling the user, hello Mike, hello John, hello Paul, hello Peter, how are you doing, and so on. So yeah, that's the simple way this works. Okay, so let's look at operations in Python. We have arithmetical operations, that's the normal mathematical operations that we know, and we have the operations used for comparison, less than, greater than, and the rest, and we have logical operations. So from our code snippet, as you can see, if we declare x to be equal to 5, x is a variable and y is also a variable. They are known variables, so we know that x is equal to 5 and y is equal to 3. We can print these two, so if we print x plus y, uh, definitely you know the answer. Python is going to take x, the value of x, the value in the box of x, and the value inside the box of y, and put them together to give us 8. So when we print x plus y, we will have 8. And now the next one there, it tries to compare. So if x is greater than y, which is true because 5 is greater than 3, and x is not equal to y, then that is actually a true condition. Why? Because in the first case, x is greater than y, which is true, and we know that the logical gate AND only proves true if both x and y, if both inputs are true. Otherwise, it returns false. So for this case, as we can see that the right hand side is true where x is greater than y, and the left hand side is also true where x is not equal to y. So that implies that we'll also have a true condition there. Now, almost every programming language uh, is logical. You can perform a whole lot of logical operations in Node.js, in C++, in C, in PHP, and the rest. Okay, so let's go on. So we also have control flow systems. So we can actually do some things. We can tell Python to do some things if a condition is met. So we declare the variable, for instance, and that variable is 9, is 10, is 10. So the name of that variable is num, as you can see on screen, and we assign the value of 10 to that variable. Okay, so this is what I'm talking about right here. So we assign the value of 10 to this variable called num. Now, if num is greater than 5, we print that the number is greater than 5, else we print it is less than 5. Now, based on this condition, it is definitely true that 10 is greater than 5, and because of that we will end up printing this, and this part of the code would not run since num is equal to 10. Okay, so we also have what we call loops. Loops, think of loops like a cycle, things that will continue indefinitely until you provide a stop for them. So there are a lot of ways we can create loops. Well, let's look at the for loop and the while loop. They are very common. So for the for loop, we declare that if I is in the range of 3, what this means is in the range of 3, numbers from 0 up to that range will actually be taken. So we are looking at 0, 1, 2, and we will print out those items. So right here you can see we will print out those items. We love the for loops most times because it is very simple to construct. But for the while loop here, you have to first of all declare the variable as the count variable. So now we have it that the count variable is assigned the value of 0. If count is less than 3, this will be false. For the very first section, for the very first section where count is equal to 0, this would walk through and this will run. But as we continue to increment it, it gets to a point where it becomes false. Okay, so in that, if this is 0 and 0 is less than 3, this code runs, and right here we are adding 1 to count, so count automatically becomes 1. 1 is less than 3, so this will go again, and after it's done running we add 1 again. Now 2 is less than 3, this runs, we add 1 again. Now when it happens the next time, it won't really be able to run because 3 is not less than 3, so it will be false, and this whole code section will stop running. There's something I didn't say when we started. uh, in most programming languages we use curly braces, but here in Python we use indentation. So you can see that my code is indented properly for every condition I bring in, for every loop I bring in. If you go back to where we had if statements, you can see that the print commands that I intend to run inside that condition are indented properly. So failure to indent your code will lead to a lot of errors. So indentation is what we use here in Python, and it also makes the code much more readable and easy to understand. Yeah. So we have built-in functions and libraries in Python that will make your life very easy. So there are libraries or packages, as the case may be. Our JS brothers used to love to call them libraries, but just know these are simple code that has been written to help you achieve some very simple stuff. So we have the input, which of course is very common. The print, the len will give you the length of a variable, be it a string, be it a dictionary, be it a list. It will give you yeah. So we also have um, the math package. So if you import this, you can do a lot of things with it. It comes with a lot of methods, but here you can see we use the square root method. We have the sine method, the tangent method, the root, this is the square root, the square method, and so on. By default, Python also comes with random. So if you want to randomly select something, so you want to randomly create a number in the range of 0 and 10, you can do that. As you can see, that's what we did on screen. Okay, so defining functions. So functions are a set of commands that help us achieve a set goal. So most times we can declare functions and we tell the function what to return. Sometimes we can declare a void function. Now, unlike other programming languages that make it very complex, Python has reduced all of that. You just have to declare it. If you intend to return something, you return. If you don't, you just go on with your code and nothing bad happens. All right, so that's how you declare a function with def, and you can see how we use that function. So
Hello, my name is Kenyo, and today we'll be looking at practical examples on how to learn Python. Okay, so you see, I believe I'm one of those people that believe that if you spend um, 2 to 3 hours doing the same thing every day, you gain mastery over it. So one of the best ways to learn programming is by solving problems by looking for real world application and seeing how you can, solve some of these problems with your skills. So we're going to look at live examples in this video. This video is totally going to be about examples, practical examples, and we'll attempt to solve those examples. Okay, so the very first example here is, let's assume a hospital has called on you as a Python guy to create some computer code to differentiate between adults and children. Given their age, every patient under the age of 18 is regarded as a child. So you have to write Python code where the user imputes their age, and you can tell them if they're a child or if they're adults. Okay, or if they're an adult, yeah. So let's go straight. First off, you need to open up your IDE. I'm using VS Code. Um, we're going to create a folder called Python for this experiment, and in it we'll create a file and we'll call it test. Um, let's call it practical1.py. And we're going to attempt to solve that problem here. Okay, so let's have the problem this way. Okay, so once again, a hospital has called on you to create some computer code to differentiate between adults and children given their age. So what we need as input is the age of the user. So we're going to create a variable, and we will demand that the user enter their age. Okay, so when the user runs this code, the very first thing they should see is a prompt to enter their name on CLI. But age in itself, you can use the comment section to tell me what do you think is the best data type to use for age. Yeah, I mean, I'm giving you time to use the comment section. Okay, yeah, so let's go straight so I don't waste anybody's time. We can pause the video and just and try. So the best data type we can use here is int, is integer, because age is a number, like normal counting number. So yeah, an integer will be the best to use in this case. So the age variable that is now the integer is equal to the int of age. Now in Python, to convert string, the data we get from users are always in the format of strings. So to convert strings to integer, we use this global function or method called int. It will help us do that conversion. Now my AI tool I paired up with my VS Code is already suggesting a conclusion to this. Yeah, so we will then add some condition. As you can see already, it's already on screen. The AI tool is already has a clue about what I intend to do. We're going to create this if statement here, make the print that the person is a minor if they are less than 18, and if their else if their age is greater than 18, um, yeah, we can adopt this. We can adopt this. It's still cool. Uh, Else we print out some last words. Um, all right. And let's not make it an overkill. I think this does the job. Our intention is not really to go on with all of this. But I just felt since the AI tool is suggesting we can also include this area. But the main goal is to just make sure we capture the minors. Okay. So when we run this code, in VS Code, there's always a play button here. Else, if you come on terminal, you can call Python and call the location of your file to run the code. So if we use the play button here to get our script running, enter your age. Let's assume we are 6 years old. What happens? You are a minor, so you don't have access. When we run the code again and we say we are 23 years of age, what happens? We have an error. So now this is where the skill as programmers come in. Now I want you to use the comment section. You can pause this video. Just looking at the output from the code. Where do you think the problem is? Okay, so let's solve it. It's very simple. Now here, as you look at age here is a string. What we are supposed to use here is age int. That is a number. So what we are doing here is we are comparing a string, which is not numeric, with a numeric data. So it's just like you say is hello world greater than 18. All of those stuffs, they come in as string. So we have to use the default variable we created, which is int for this use case. That's why it's good to know exactly what you are doing, because sometimes these AI tools that we use can suggest code that are erroneous, and if you just don't understand, you just mess up everything. So let's go again. 23 and you're an adult. Let's go again. We say we're 45 and you're an adult. Let's go again and we said we are 70. It says you're a senior citizen. So we have solved that problem. Practical problem 1 solved. Let's go on to practical problem 2. Let's create another file. uh, I think I'll be solving just two problems here. Now this is in another niche where blog and writing. A post-blog organization has asked you to write some lines of code for them. The code is supposed to get inputs from the users and print the same data back to the user. So it's very simple. So we intend to get data from a user and print same data back to the user. So once again, we're going to create a variable called data, and we're going to get input from the user. We'll tell the user to enter their blog content. Um, then what else? The next thing we're going to do is to print out whatever we get above there back to the user. Now these two lines of code solve this problem. So if we run, we're in practical 2 now, so let me change that to 2. Enter block content. Block content is need some random words and on the mother. Yeah, it prints out the trash I typed up above back to me. But let's give this some good usage. Let's just comment this out a little bit. I will do some little trick here, copy this, and let's give this usage. Let's say enter your name, right? And we want to give a salutation, like a welcome. So we just want to say welcome. So we want to welcome you, including your name there. Now, this is where what we talked about before now comes into play. We have to perform what is called concatenation. Concatenation is when you bring two strings together so that they can appear as one. So we just use the plus sign there to perform concatenation. This is one way of doing it. Another way of doing it is you can use the format or you can use the curly braces. Um, we can also yeah, so we can do it this way or this way. There are a lot of ways you can do it. You can use formats. There are just too many. So when we run this again, we enter our name. My name is Nkenyo and I click enter. You can see the first one outputs this and the second one outputs this. There's just no difference. It's practically the same thing. But the lines of code look a little bit different. Yeah. So that's that. I think we have solved this particular issue. Let's move on to, all right, let's move on to the third one. Okay, so this is a military setting, right? Practical number three. Practical three. This is a military setting. A general has hired you as a Python dev to write lines of computer code to detect if a person has passed the physical fitness slash quality test, I believe, of the recruitment process. You are only giving the height of the person and their gender. Now, the condition of someone to pass is um, anybody, male, below the height of 60 inches is disqualified and any female below the height of 58 inches is disqualified. So we have two parameters and now you see the parameters are increasing. So we have two parameters here. The first one is the height of the person. Now, instead of us calling the input first and then later performing conversion, we can actually create a chain of events so that it becomes very easy for us. So where we can call input um, yeah, I think this file was not saved properly. I made a mistake while saving this file. You can also guess the mistake. You can see VS Code is not bringing out the colors as it's supposed to. So I used a comma here instead of a full stop. Aha. Okay, so we have the height. We have the gender. Um, Gender in this case can be male or female. So we can use integers to represent that, or we can use full words. But it's best we just use full words, as that will make our code more understandable. Okay, so since the height of the person is going to be integer or float, we can use the float here to wrap up the entire input so that automatically height is always a float. Yeah. So gender by default will be string because the default data type returned by input is string. Okay, so we'll move on a little bit. The first condition for male is that if the person is male. So if gender uh, is equal to male, um, okay, then if gender is equal to male, and um, this is where we can now bring in gates and all of that, and the height is less than 60 inches, that person should be disqualified. Mm, uh, Okay, that's very good. So else if in Python is written that way, else if gender is equal to female, um, and height is less than 58, um, then we print. Okay, I think that's good. Then finally, we make room for those who are qualified. Okay, that looks very good now. Okay, so we're just going to run this. We're in practical 3 now. So what's the height? Let's assume this guy is 45 inches and he's male, right? It says you are disqualified. But what happens when someone maybe uses uppercase for the male? Let's try that. Let's try that. That would be very important. 67 as height, which should be qualified, and he's a male. Let's use capital M. And it says you are disqualified. Now, the reason behind this is because we used lowercase, everything here is lowercase, that's everything here is small letter, while here the mail was written with capital letter. So how do we handle that here? Yeah, you can also use the comment section. um, so I'm just going to drop out this line, then I'll provide the solution here. So first off, whatever gender we get, we can solve this in different ways, but I'm just looking at the simplest approach we can take. The simplest approach, I believe, is to call the gender and convert it to lowercase. Either way, it helps reduce all of the stress. So if it is block format, no matter the format the person uses. So far, we are converting it back and comparing it with the lowercase so that we don't have any problem there. Okay, so when we run this and we provide the same input and we say male, says you are qualified now. This is a full solution to problem 3, and it works just fine. Yeah. Okay, so you can continue playing with that. You stumble upon bugs like I just did. I try to make sure that I did not record this video like knowing everything about the problem so that you could see me maybe confused at some point, which I don't really like being confused. But it's good. The core aim of this video is for you to play around and at least understand how to find bugs and how to solve them. Okay, bye for now.
Hello everybody. In this video, we're talking about arithmetic operators, systems for comparison, logical operations, and assignments. In the previous video, we talked about variables and we looked at the principle of assignment where we can create a variable which is practically a name and we can assign some data to that variable. The data here can range from different data types, from strings to integers to floats to dictionaries to lists. We are around with a lot of things. And to assign a value to a variable, you just use the simple equality sign. But today we're going to look at a whole lot of other signs we can use when writing lines of code. The arithmetic operators, which are very common mathematical operations like addition, division, multiplication, and subtraction. Uh, we can see the signs up here. And when we begin to compare things to see if things are less than, greater than, if they are greater than or equal to, or they are less than or equal to, or if they are equal to, For equality, you see, we use two uh, equal to signs. We use two equality signs. And here, the last one there means it's not equal to an exclamation mark with the equality sign. Now, some other very unique ones are integer division and the remainder stuff we call model in some cases. These two are very unique. This divides to an integer and the last one returns the remainder. Uh, the last three things there, which are more of like gate systems, are the very popular and or not. So they are also used in Python. If you want to uh, create a scenario where if uh, two conditions are met, then the logic gate should open up. So you can use an if statement, and in the condition box you can actually bring in the AND gates or the or to to make it very logical. Yeah, so we're going to do a little test run around some of these things. But before we do that, if you've got Python installed, you can go straight to the console. Here we will just practicalize with a few things. Uh, 3 equal to this. It gives us basic syntax error because it doesn't really understand what we are saying, because the equal to sign is used for assignment, not to check equality. Remember, that's very important. So if we do this, um, we should get false. The pattern is telling us that definitely 3 is not equal to 5. But if we have 5 equal to 5, it gives us true because definitely 5 is equal to 5. Other arithmetic operations can also be carried out either in code in the file or in the console like I'm trying to do here. So you can be free to play around with all of this. You observe that when we divide a number, even though we're supposed to get an integer, uh, we automatically will get a float. For instance, 6 divided by 3 is 2, but we should have 2.0, which in fact is very logical. So the standard in most cases for division is a float. Yes, because most times when we divide, we will always have remainders. Okay, so let's go straight to making a simple example. Let's assume we get a number from a user and we check if that number is greater than 0 or less than 0. Okay, so let's assume our norm is equal to the inputs that the user will provide. Um, for this particular case, I would attempt not to use my AI tool, but the AI tool already knows, and it's good to use the AI tool. It just gives you very, very good code, and you can fine tune it, if you know exactly what you're doing. So, first off, we have to convert that, and then we then check after conversion if it's less than 0. If it's less than 0, we want to say, this is a negative number, and if this set of number, if this number is greater than 0, we know for sure that this is a positive number. Okay, and finally, uh, if all of these cases are met, I believe the last case will be that it is 0 itself. So I'm just going to save that and we'll use the play button right here. Let me kill this and clear it. Then we use the play button right here. We enter a number 40, the number is positive. We enter another number 10, uh, that's a positive number. We can also check the downside like minus 30, that's a negative number, and the code works very well. But we begin to have errors when we enter numbers that are not numbers, when we enter things that are not numbers. Yeah, so we can always try and use the except, try and catch system,
So we're going to put this into a try system. This also helps us to, check out for errors. Okay. So if we do repeat, uh, that's positive. If we do repeat it with an invalid number, uh, we get our system which is fired up. So A here in this case is not defined. Yes, let's fix that. We don't even need A in that case because I'm not actually using it. Yeah. So yeah, this is an invalid number. Okay, yeah. So I think we have done a little demo with this, and we have come to the end of the simple explanation on how the arithmetic operations and the logical systems here and system of comparison here works. So yeah, on to the next one. Bye for now.
Hello everyone. In this video, we'll be looking at two very important sections. The first one is the control flow, which involves things like the if statements, the switch case statements, and loops. Or when representing those items in the flow chart, we use triangles to show that flow control. And then we will look at another part of this video that will be about Python's built-in functions and libraries. Okay, so let's go straight into it. So let's assume we have a variable uh, which of course is equal to 6, and another string variable which is equal to some random string. So what we intend to do here is to see how we can play around with this using some basic stuff. So first off, let's say we want to create an if statement. The very first thing you might have seen in our previous video, Python's if statement is created this way. Indentation is a very important thing in Python, so you must always indent your code. So if num is equal to 5, we want to print out some random stuff saying maybe this is 5. Okay, all right. So that is the simple way we can actually make an if statement. But what makes if statements much more interesting is that you can actually include other conditions, like using the elif to in fact add another condition. uh, and as you keep going, you can continue to add other conditions. At the end of everything, if you do like, you can include an else statement that the else statement is always going to run if no other condition is met. All right, so basically that's how our code will look like. So how do we create loops in Python? There are a lot of ways we can create loops. We have the do while approach, the while approach, and the for loop. But basically, as you read that up, you can always use the for loop. It's very simple and modern. We can do something like for I in the range of num, and we can automatically fire from here. Yeah, so let's we can always use the range. It's very important. Okay, so let's run all of this together. So you can see here, what we have is 0 to 4. The range here would return a set of values below the specified integer. That's to say 5 itself is not inclusive. So that will be 0 to 4. So if we do increase this to 10, it will now be 0 to 9. Yeah, all right. So yeah, that's a simple way we can do that. We can also use the while. If num is greater than 0, of course, or we can continue to print something. Mm. This becomes a lot more interesting because some people make this error and they get an infinite loop. Okay, so what do I mean by infinite loop? I think the best explanation is just for you to see it. This is an infinite loop. My system gets hooked continuously printing this stuff. And as you can see, I'm scrolling and it looks like I'm not scrolling. Um, so this is really, really bad. You don't want to do that. So to avoid that, you need to also adjust the state of norm so that norm will be equal to uh, norm minus 1 in this case. So if we do that, we're going to just have five printouts. So that's to say the code inside this while loop is run just 5 times. Yeah. All right, I think that's a simple explanation to what we intend or what the control flow of things is. One other thing I would like to share before I stop this video are the built-in libraries. Python comes with some very powerful set of built-in libraries. The first one is the math library. You can use this for basic mathematical operations like finding the square root, the cube root, and so on. We also have a very interesting one called the random library. The random library is very important. As you can see the use case here, you can use to get random numbers, from random integers to getting random floats to even selecting stuffs at random from a list. You can use the random library. We also have the date and time library. This is a very important library as it helps you get the precise time. It also helps you get minutes, seconds, and a lot of things around time. Another very powerful one is the OS library. This works with the operating system. If it's Linux, if it's Windows, helps you get the working directories, the paths to different things, and it helps you easily manipulate and move around areas in your PC. Yeah, so this is very synonymous to the OS library. In this case, you can see how I've used it here to get the version of Python running on this particular system. Here I use the OS module to get the working directory, the current directory of where this code is being run. And last but not least, the JSON library. This is very important as you advance, especially when you begin to build APIs and when you begin to do stuff around data sets and data science. It's a very, very important one. I use it here. You can see I created a kind of dictionary, change it into a JSON, and then in this particular state you can move it across servers, you can send it to your DB, you can print it out, you can do a lot of things, and it makes the work much more easier, using JSON to present data. So with this video, I hope you understand some basic stuff and you understand some of the built-in Python libraries that you can use day to day. Now these built-in Python libraries, they don't need to be installed. That's why they are called the built-in Python libraries. You don't need to pip install them like some other libraries like the pandas library or the numpy, or these ones are shipped automatically with Python. So the moment you install Python, you have access to all of these libraries and you can use them to manipulate different things and play around with your OS. So I'd like you to test them out do different projects around this and give me feedback. Uh, till we meet again, I think we are done for today. Have a nice day. Okay, so hello everyone. So in this particular video, we'll be looking at how to create your custom functions and your models and how you can use them across different files. So say you're building an application, and in that application, there are some unique set of functions that you are using most of the time. So you need to kind of put these functions in a utility file, and you can call them from anywhere within your app. So as you can see here on screen, I have my main application, my main Python file here, and I also have my utilities, which are some set of functions. Now, if you don't know how to create a function in Python, it's very simple. You just have to define the diff, the def. Immediately you call this, you give the function a name, and if the function is to accept parameters, you provide those set of parameters. They can be as many as you want them to be. It depends on what you're building and how you want your function to operate. Okay, so here you can see I have three functions in my utilities. I have named it my utils.py. The first one is the greet function, the second one is the add, and the factorial function. For those of us that are not very conversant with the system of factorial, it is just the backward multiplication of numbers. So if I have 5 factorial, it means 5 times 4 times 3 times 2 times 1. If I'm not mistaken, I think that's what it means. So yeah, so I intend to use this right in my code. So here in my application, in my main Python file, you can see that I can import this particular file. Me importing this particular file simply means that all of these now I can use on my code. So when I call my utilities.greet, it is similar to just calling this guy. And when I call my utilities.add, my utilities.factorial. Now you may be thinking, why are we doing this? Now, if you begin to build a lot of applications where there are a lot of things going on, you need to group those utilities. You need to put those particular functions in a different location in most cases, so that they are easy to accept. So that if this is one page, this is another page, they can all be linked to my utilities. Yeah, so I'm just going to run this. I already did, but let me just do it again. So as you can see here, uh, it gives out hello, my name, and the set of addiction, and it factorizes here. So that backward multiplication will be 1 to 0. We change this here. We don't now. The interesting thing about building modules of this kind, when you predefine your custom functions and import them, is that you don't need to adjust things in this file anymore. For instance, all I need to do is to just change content from here and change some basic stuff here. I don't need to go back to uh, the other file, the modules file. So I'm just going to save this, and I'm going to run this again so we see. Yeah, so you see, we can also change this to be the factorial of 10. I'm just going to save this, and I'm going to run this. So you see the change there. All the changes we did were here, not on this. So with this simple approach now, you can also build your set of modules that you can ship out to people to use, right? So those modules we use, those libraries, I'm using those words, modules, packages, and libraries interchangeably. So those libraries that you use, like NumPy, like math, like the OS library that is built in, like the sys, that's the system library, and the JSON library, the random library, and so on and so forth. You know, you don't actually adjust those libraries because they are predefined like this. So you can also build your models and ship them out. Package, you know, of course, we have a package manager called people, but Python also has a website where most of these tools are open source. So you can actually create your own library to handle a particular problem, and you make it open source, you put it out there, people install it and they can use it all around. Yeah, so it's as simple as that. In our next video, we'll try to go a little bit deep. In some of my previous videos, you may have seen that I may have been struggling with some basic syntax in some cases because it's a lot of things, happening in the brain, and sometimes when put under tension and stress, we tend to forget a lot of things. That's where AI programming comes in. Programming with an AI companion is very, very good. I won't say it undermines it actually increases your efficiency. But what I want to advise is when you don't understand the basics and you just go straight up to using AI tools, because that will make it a lot more complex to you. If you are too dependent on the AI tool, you won't know if the AI tool is actually making some mistake. You won't know if the AI tool is actually making some errors. So I have a lot of AI tools here, but for some stuffs I just keep them aside. And sometimes it's best when you check out the code the AI is providing and you go through it and make sure that okay, this is actually good. It's also good if you pair up AI tools. One writes the code, the other one reviews, and you are just there to test. That is also another very interesting thing to do. But as the set of problems keep increasing, as the problems keep going up and up and up, you may want to redefine the approach so that it is not just AI systems. You are actually actively involved. Yeah. So thank you very much. The battery is low and this is the end of this particular video. Hopefully see you in the next one when we'll talk about some more Python stuff. Bye.